Students, Assalamu alaikum. Hope so you are really enjoying your vacations. Today we will talk about alkane. We will deeply study its nomenclature, and in the end I will put some examples in front of you that will help you how to assign a systematic name of the alkane. So kindly like, subscribe and share my channel. So let's start the discussion. So students, today we will discuss about alkane. We will deeply discuss its nomenclature. So let's start. What are alkane? Alkane are basically hydrocarbons. Hydrocarbons, it means what are hydrocarbons? Hydrocarbons are composed of two atoms. It means composed of hydro, it means hydrogen, and carbon means carbon. So you will generally define as hydrocarbon are the compound composed of hydrogen and carbon are generally known as hydrocarbons. So we classify hydrocarbon into two main types. One are saturated hydrocarbon and other is unsaturated hydrocarbon. We generally call saturated hydrocarbon are those hydrocarbon which contain single bond, while unsaturated hydrocarbon are those hydrocarbon which contain double or even triple bond. So in saturated hydrocarbon, we generally classify alkane. Alkanes are saturated hydrocarbon, while in unsaturated hydrocarbon, we classify alkene, alkyne, and benzene. These three all are unsaturated hydrocarbons. So here it is an ethane. Ethane is an alkane. It is a saturated hydrocarbon, while this is an ethylene. Ethylene is an alkene. It is unsaturated, while acetylene, it is an alkyne. It is also unsaturated hydrocarbon, while benzene, it is also unsaturated hydrocarbon. So today we will discuss about alkanes. The general formula of alkane is CnH2n plus 2. While n is an integer, its value start from 1 to onward. When the value of n is 1, the structure which is formed as known as methane. So let's move further. IUPAC rules of alkane, International Union of Pure and Applied Chemistry rule of alkane. So first important point which should be kept in mind while naming the alkane is that identify the parent chain. So identify the parent chain, it means that we select the chain which contain largest number of carbon atom. So here it is one of the most important point is that we identify the parent chain. Second important point which we'll discuss later, identify and name the substituents. So substituent is something like branches growing on the trees. So our task is that we identify the substituents, and after that we name the substituents which are attached to the parent chain. So third important point which should be kept in mind, number the parent chain. So our third target is that in the end we number the parent chain, assign when we number the parent chain, automatically we assign a locant to each substituents. So four important points, list the numbered substituent before the parent name in alphabetical order. So fourth important point is that we numbered the substituent on the basis of alphabets. For example, if the name of substituent start from A, we will number that first, and when the number of substituents when start with B, we will number is second. So on the basis of on the basis of substituents, we will classify it on the basis of alphabetical order. These are all the 4 points which should be kept in mind while naming the IUPAC rule of alkane. So let's move further. Selecting the parent chains. It is the most important point of naming the alkane is that selecting the parent chain. So while selecting the parent chain, we must be aware of the parent name of alkane. For example, when number of carbon is 1, the structure which is formed is known as methane. When number of carbon is 2, the structure which is formed as ethane. And so on, when the number of carbon is 9, the structure which is formed as nonane. And when number of carbon are 10, the structure which is formed as decane. When number of carbon are 11, the name of alkane is undecane. When number of carbon are 12, the name of structure which is formed, name of alkane which is formed as known as dodecane. When number of carbon 13, the structure which is formed as tridecane. When number of carbon are 14, the structure which is formed as tetradecane. When number of carbon are 15, the name of alkane which is formed as pentadecane. When number of carbon are 20, the structure which is formed as icosane. And 30, tricontane. When number of carbon are 40, the structure which is formed as tetracontane. While number of carbon are 50, the structure which is known as pentacontane. And when number of carbons in a longest chain are 100, the name of parent chain which is formed known as hectane. So it is very important to study the parent name or to learn the parent name of the alkane before going to IUPAC name of the alkane. So the first point is to identify the parent chain. Identify the parent chain, it means that locate the longest continuous chain of the carbon atom. Our main target is to identify the longest chain of carbon atom. So when we saw this structure, we will number start from there. 1, 2, 3, 4, 5, 6. This chain contains 6 carbon atom. But when we move from 1, 2, 3, 4, 5, 6, 7, when we number from this side, it contains 7 carbon atoms, so it must be heptane. But when we number from there, 1, 2, 3, 4, 5, 6, 7, 8, it contains 8 carbon, so it might be octane. But when we number from there, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is the longest chain which contains 9 carbon atoms, so it must be octane. So we select this chain 1, 2, 3, 4, 5, 6, 7, 8, 9. So this chain is our longest chain. So our main target is to identify the parent chain, the chain which contains longest number of carbon atom. So our chain is this one because it contains 9 carbon atom, while rest of the chain contain either 7, 6 or 8 carbon atom. So our first point is to identify the parent chain. So if the second important point of selecting the parent chain is that if there is more than one possible parent chain, choose the one with the most substituent attached. So when there is a tie in the selection of parent chain, our second criteria of selection of parent chain is that we must choose the chain with most substituent attached, with more branched are attached. So when we look this structure 1, 2, 3, 4, 5, 6, 7, this chain contains 7 carbon atoms and this is our longest chain. And this chain contains 1, 2, 3. And this chain contains 3 substituents. While when we talk about when we talk about the same structure, but we numbered from here 1, 2, 3, 4, 5, 6, 7. This chain also contains 7 carbon atoms, but where number of substituents are 1 and 2. So our correct structure of selection of parent chain is that because it contains largest number of substituents. So our third important point is that identify and name the substituents. A ring can either be a parent chain or a substituent depending on the number of carbons. So it means that ring can either be act as a parent chain and it can also be a substituents depending upon the number of carbons. So when number of carbon atoms are greater than it is assigned as a parent chain. When number of carbon are smaller than the substituent, then it is assigned as a substituents. So let's talk about this. This is a cyclohexanes and this is a propyl group. This chain contain longest cyclic structure contain largest number of carbon atoms. It contains 6 carbon while this contains 1, 2, 3, 3 carbon. So this is our parent chain and this is our substituents. So the correct name of the structure is that propyl cyclohexane because we first write the name of substituent and after we write the name of parent chain. So when we talk about this structure, the cyclic structure contains 3 carbon while this chain, longest chain contains 4 carbon. It is the longest chain, so it is our parent chain. So here this one position contains cyclopropyl group, so we named as 1-cyclopropyl butane. So the important thing is that a ring can either be a parent chain or a substituent depending on the number of carbon atom. Greater the number of carbon atom, it will assign as a parent chain. If number of carbon in a cyclic ring are less, then it will be act as a substituents. So 4 important point: identify and name the substituents. So we must identify and after that we name the substituents. So when we talk about this structure, this longest chain 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This longest chain contains 10 carbon atom, so it is a decane. When we talk about substituents, there is one substituent attached there and the other substituent attached there and while other substituent is attached there. So this substituent is known as ethyl because it contains 2 carbon. This substituent contains 3 carbon, so it is a propyl, while this substituent contains 1 carbon, so it is a methyl. So our task is that we identify the substituents, and after that we name the substituents in the alphabetical order. So when two substituents, let's move fifth point, when two substituents are present on the same carbon atom, use the number twice. Numbers are separated from words by hyphen. It means when the two substituents are attached on the same carbon atom, we repeat the position, we repeat the locant of that carbon. For example, when we number from there 1, 2, 3, 4, the 4 carbon contain two substituents. It contain one side ethyl group and other side contain methyl group. When we select the longest chain 1, 2, 3, 4, 5, 6, 7, 8, the longest chain contain 8 carbon atom. So it is an octane. So in the end, parent chain is an octane. But before the parent chain, we write the name of substituents, and the name of substituents is written in alphabetical order. So when we talk about this is an ethane, and we know ethane start from E, so E come first while methyl M come later. So we will number in this way that it is an 4-ethyl 4-methyl octane, because we number the substituents on the basis of alphabets. So let's move further. Number the longest chain beginning from the end of the chain near to the substituents. So our target is that we must number the substituents. We must give the substituent lower possible number. When we start from there, 1, 2, 3, 4, 5, 6, 7. The parent chain contains 7 carbon atom, and here its substituents gets 2 position. While here when we number start the same structure, when we number from right side 1, 2, 3, 4, 5, 6, 7, the substituent gets 6 number. So this is a incorrect structure. This is a correct structure because the substituent should get the lowest possible number. ताकते रहते तुझको numbering of the parent chain. So move third point, carbon in the parent chain have to be numbered. The carbon which is attached in a parent chain or a substituent which is attached in a parent chain have to be numbered. 1, 2, 3, 4, 5. The parent chain contains 5 carbons, so it is a pentane, and its 2 position contain a substituent which is known as methyl. So the right structure is 2-methyl pentane. So when we right name is 2-methyl pentane. When we number from 1, 2, 3, 4, 5, the parent chain contains 5 carbon atoms, so it is a pentane, while on third position it contains a methyl group, so its correct name is 3-methyl pentane. 2-methyl pentane means that a methyl group on a carbon number 2 of the parent chain, while when 3-methyl pentane means that there is a methyl group on the carbon number 3 of the pentane chain. So in this way, we assign the parent chain a number. Let's move towards 4 point. If there is a tie, then number the parent chain so that the second locant gets the lowest possible number. If the first locant gets the same number, then we will move towards the second locants. For example, when we number the structure from there, 1, 2, 3, 4, 5, 6, 7, the parent chain contains 7 carbon atom and it contains 1, 2, 3 substituents. So when we number from there, its 2 position contain methyl group, 3 position contain methyl group, and 6 position contain methyl group. So 2, 3, and 6 are the locant of the substituents. When we assign this structure from the left direction, so 1, 2, 3, 4, 5, 6, 7, the second position contains the substituents, and 5th position and the 6th position contain the substituents. When we compare these two, the first locant gets the equal number. So we cannot decide on the basis of this. When we move further, here these substituents contain, this structure contain 3, while this gets number 5th. So this is our right structure because here the substituents is getting the lower possible number, while here the substituent is getting the highest number. So this is our right structure, this is our wrong structure. So we'll move towards 5th point. If there is no other tiebreaker, then assign the lower number alphabetically. When we cannot assign the substituents, then our main focus, our target is that we assign the lowest number alphabetically on the basis of alphabets. For example, this is a structure we can assign from either, we will assign from either right or toward or from left. When we assign from right, 1, 2, 3, 4, 5, it is a 1 position contain bromo, 1 bromo. And when we will number this structure from this direction, 1, 2, 3, 4, 5, its 1 position contain chloro. So when we get alphabetically, we know that in B come first and C come later in alphabets. So 1 bromo beats 1 chloro. So this is a correct structure, this is a incorrect structure, this is an incorrect numbering of the parent chain, and this is a correct numbering of the parent chain, because we are numbering here on the basis of alphabets, and when we know that B come first and C come later. So now we assembling the IUPAC name. So to assemble the complete name, I have summarized all these points which we studied earlier. So first point is put the number and name of the substituents before the parent name in alphabetical order. It means that we first write the name of substituents in alphabetical order, and after that we write the name of the parent chain. So numbers are separated from words by a hyphen. We separate the numbers from words by a hyphen. For example, if we want to write 5-methyl, then there is a hyphen between 5 and methyl. So second point is a prefix is used, di, tri, tetra, penta if multiple substituents are identical. For example, if there is a substituents between 2 position and 4 position, same substituents, then we use di, prefix is used. So commas are used to separate number from each other. For example, if we want to separate 2 or 4, then we use comma in order to separate these number. Note di, tri is ignored when alphabetizing the substituents. When we arrange the substituents on the basis of alphabets, then we will ignore the di, tri, or tetra, or even penta prefixes. So let's move. So IUPAC rules. So finally we assign a structure. Following the rules, we can name the following compounds. For example, so this is a cyclic structure. We know a cyclic structure contains 6 carbons. So it is our longest chain. 1, 2, 3, 4, 5, 6, and it's contain 1, 2, 3, 4 substituents. Contain 4 substituents on it. So that starts. 1 position contain a tertiary butyl group. Second position contain an ethyl group, while 4th position contain methyl group. So its correct name is 1 tertiary butyl. Why butyl first? Because it B come first. While 2 ethyl, second position contain ethyl group, E come later, and 4 dimethyl cyclohexane, because in dimethyl M come later. So we arrange these substituents on the basis of alphabets, and after that we write the name of the parent chain. This is all about today's lecture. Kindly like, subscribe my channel. If you like the content, display there.